Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will study about the line of constant stream function, then we will study about the equipotential line, then we will study about the what is flow net, and we will also see relation between stream function and velocity function. So first of all, stream function is basically defined for two-dimensional flow. So first of all we will write everything in 2D only. So let's see what is the stream function and what is the potential function. So if you see in our previous video, then we have already studied about them, but let's just write in brief. If phi is a stream function, okay, phi is function of x and y. It is also function of time, but we are considering a steady flow so we will neglect time because it will become constant, and it is defined in three-dimensional, but a stream function is defined in two-dimensional, so we will also write it in two-dimension. Okay, and psi is function of, this is stream function, this is potential function. Psi is function of xy, these two are function of xy. Now what is phi? See, del phi upon del x is equal to minus u, del phi upon del y is equal to minus v. So we know this formula, and how it can be defined, that equipotential function, potential function is the function for which a derivative in that direction gives negative of velocity in that direction. Means if we are taking derivative with respect to x, then it will give velocity in same x direction only, and it will be negative. Similarly, del phi upon del y del x is equal to v, and del psi upon del y is equal to minus u. Okay, so for stream function, derivative in x direction gives velocity perpendicular to that direction. Okay, so we are doing derivative with respect to x, but it is giving velocity in y direction, which is v. Okay, here also, and here you have to remember that it is minus. Okay, so this is a stream function and potential function. Now we know that potential function phi is function of x and y, so we can write from chain rule that d phi is equal to del phi upon del x into dx plus del phi upon del y into dy. So what is chain rule? We have written this formula from chain rule. So what is chain rule? If this is phi and this is function of x and y, then we can write d phi is equal to partial derivative of x plus partial derivative of y, and it will be multiplied by dx and dy respectively. Okay, if it was z also here, then we will also write del phi upon del z into dz. Okay, so now from here we will write the values here. So d phi will become del phi upon del x is minus u into dx, and del phi upon del y is minus v into dy. And what is equipotential line? As we have written here, equipotential line is a line along which the velocity potential phi is constant. So if we are considering equipotential line, then this phi will be constant, and d phi will be derivative of that constant will be 0. So it will become 0 is equal to minus u dx minus v dy. But this is only for equipotential lines. Okay, so for equipotential lines you can also write u dx is equal to v dy, or dy by dx is equal to u by v. Okay, so let's see again. Del phi is, d phi is del phi upon del x into dx plus del phi upon del y into dy. So d phi is equal to del phi upon del x is minus u, and del phi upon del y is minus y. So minus u dx minus u v dy is equal to 0. So u dx is equal to, this will become minus, that was the mistake here. Dy upon dx is minus u by v for equipotential line. Now dy by dx is slope, as we all know. Slope is equal to dy by dx, and it will be equal to minus u by v. Okay, and this is for equipotential line. And what is equipotential line? Line along which potential function is constant. Now for stream function psi, line of constant stream function, as we have written here, line of constant stream function, what is it? Line along which stream function is constant. Okay, so here also d psi will become 0 because stream function is constant, so its derivative will become 0. Now psi is function of x and y, so we can write from chain rule d psi is equal to del psi upon del x into dx plus del psi upon del y into dy. Now from stream function definition, you can see del psi upon del x, if you see here, is equal to v. So we will write v into dx plus del psi upon del y is minus u, so we will write minus u into dy is equal to 0 because d psi was equal to 0 because it is constant stream function line. So we can write v dx is equal to u dy, or we can also write dy by dx is equal to v by u. So this is slope of constant stream function line, and this is slope of equipotential line. So if you multiply their slope, then we will get minus u by v into v by u. So it will be cancelled and you will get minus 1. And we know that from the formula m1 into m2 is equal to minus 1. If multiplication of slopes of two lines is minus 1, then these two lines are perpendicular to each other. Okay, so it means velocity equipotential line and constant stream function line are perpendicular to each other. And from this property we will get another thing which is called flow net. So what is flow net? A grid obtained by drawing a series of equipotential line and stream function line is called a flow net. The flow net is a important tool in analyzing two-dimensional irrotational flow problems. Okay, so if this is equipotential lines, okay, then this is constant stream function line, and these two will be always as 90 degrees or perpendicular to each other. And this grid which is obtained by drawing this is called the flow net. So this is flow net. Now what is the relation between stream function and velocity potential function? If you write again, what was the stream function, velocity potential function? Del phi upon del x was minus u, and del phi upon del y was minus v. Similarly for stream function, del psi upon del x was v, and del psi upon del y was minus u. Okay, so from here you can see that minus u, it is minus u, it is minus u, those two are equal. It means del phi upon del x is equal to del psi upon del y is equal to minus u. So this is one relation between potential flow, potential function and stream function. Similarly, if we see this, del phi upon del y is equal to minus v, and it will be equal to minus del psi upon del x, because it is v, so minus will become minus v. So from here you will get del psi upon del y, del phi upon del y is equal to minus del psi upon del x. Okay, so these two represent a relationship between, or relation between, potential function and stream function. Okay, so I hope you guys understood this problem, and in our next videos we will solve some numerical problem based on the stream function and velocity potential function. And if you like this video, then please share and subscribe to our channel. Thank you for watching.